We're going to do all the same things in this video as we did in the previous video and in the example in the notes from before Thanksgiving. So step 1 will be to find the first derivative. Step 2 will be to take that first derivative and find the critical points. And then in step 3, we'll make a sign chart. And then we'll do all the same stuff with the second derivative. So let's jump in. The thing that makes this problem a little easier to deal with is it doesn't require a chain rule. It doesn't require a product rule. This is really just a power rule function. So my original function, y equals 2x to the 1/3 plus 1, I'm just recopying here. My derivative, I'm going to bring down the 1/3, times 2 becomes 2/3, and then subtract 1 from it becomes negative 2/3. And then I just drop that 1 because the derivative of 1 is 0. So I'm going to rewrite this to make it look like a fraction because that's how we just like things to look when we're dealing with critical points in the next step. So 2 on the top, 3x to the 2/3 on the bottom. Step 2 is to find the critical points. We're going to say two different things we're looking for. Y prime is equal to 0. Well, that's never going to happen. And you don't necessarily have to write that down, but you have to at least think through it. Can I take that numerator and set it equal to 0 and solve? Well, the numerator is just 2, so no, I can't do that. I can do that with the denominator, though. If I want to know where is the derivative undefined, well, that tells me that the denominator would be 0. And that's going to happen only if x is equal to 0. So I have one critical point. It's at x equals 0. Next step, I'm going to make a sign chart. The only thing that goes on my sign chart is 0. I'm going to be plugging numbers in from either side right here. And then I'm trying to figure out if I get a positive or a negative. So if I plug in a positive number, it's obviously a positive 2 on the top. And then on the bottom, I've got a positive 3. And I'm going to be taking that positive number to the 2/3 power. And think about what a 2/3 power does. It's going to square it, still positive, cube root it, still positive. So it's also going to give me a positive on the bottom. So this is going to be positive anytime I plug in a positive number. Now let's think about plugging in a negative number. I'm obviously going to have a positive on the top because the top number is just 2 no matter what. On the bottom, I'm going to plug in a negative number. I'm going to square it, and that will make it positive. And then I'll cube root it, and it will still be positive. And then I will multiply it by 3, and it will still be positive. So this 2/3 power, it's kind of like having a square there, and a square turns everything positive. So everything's going to be positive there, even if I plug in a negative number. So this looks a lot like the sign chart from the first example if you've already watched that video. Now before we answer questions, let's go back and just go ahead and do all the second derivative stuff. So we'll call this step, I don't know, it was 5 in the last example because step 4 was answering the question. So let's just keep it consistent. We'll skip step 4 for now. We'll number this one 5. We're going to find the second derivative, and then we're going to find where that's equal to 0 and undefined, and then we'll make a sign chart for that also. Now, to find my second derivative, I'm going to use this version of the first derivative that has a negative exponent on the top instead of having a denominator. So going back to this, and take the derivative of that to find the second derivative. So I'm going to have 2/3 times negative 2/3 x to the negative 5/3. So this is going to give me a negative 4 on the top. It's going to give me 9x to the 5/3 on the bottom. I'm going to set that equal to 0, which means setting the numerator equal to 0. Numerator is just a negative 4, can never be equal to 0, so no solution for that part. And again, I don't usually write that part down. I'm just doing that for your sake to let you know I did think through that. There are 2 steps here that need to happen. And then let's see, the other one is for the second derivative to be undefined, and that will require 9x to the 5/3 to be equal to 0. Whoops, that's a 3. And that only happens if x is 0, so I have just one point here. They're not called critical points. I wish they had a name, but they don't. And I'm going to put 0 on there. Now, this almost looks the same as the sign chart we had up there, but it's not, because we're going to be plugging the numbers in here. There's a different function to plug numbers in. So imagine plugging in a positive number. I'm going to have a -4 on top no matter what. If I plug in a positive number on the bottom, I'm going to take it to the 5th power, still positive. Cube root it, still positive. Multiply by 9, still positive. And a negative over a positive is going to give me a negative. Imagine plugging in a negative number. I'm going to have a negative on the top, and on the bottom, a negative number to the 5th power, negative. Cube root it, still negative. Multiply it by 9, still negative. And a negative over a negative gives you a positive. So this tells me about concavity. Remember my first derivative sign chart, and I guess I should have labeled these because there's 2 different sign charts, they mean different things. This is my first derivative sign chart up here in step 3. This is my second derivative sign chart here in step 7. My first derivative sign chart tells me my function is increasing and then still increasing. My second derivative sign chart tells me my function is concave up and then concave down. So the way this is going to look, if you're concave up and concave down but never decreasing, it's like this, what we know a cubic function to look like. So concave up over here on the left, concave down here on the right, but this is just going to be still increasing the whole way. All right, so let's answer the questions. The first question was, where does the function have a horizontal tangent line? Well, horizontal tangent line means the slope is 0, which means the derivative is 0. And we already said the derivative is never 0, so no horizontal tangent lines. The next question, where is the function increasing and decreasing? We get that from the sign chart. So increasing on the first interval, still increasing on the next interval. It's increasing everywhere, never decreasing. So let's write those out. So here's how I write these along with the justification. So these statements underneath that say because, that's where you justify your answer. In order to find horizontal tangents, we're looking for a place where y prime is equal to 0. That never happens, so we can say no horizontal tangents because y is never equal to 0. Y is increasing on the whole interval from -infinity to infinity because y prime is positive. So y is increasing whenever y prime is positive. Y is decreasing whenever y prime is negative. So we can say y is never decreasing because y prime is never negative. Now the next question asks to find relative maximums and minimums. C, the relative extrema of the function. To find relative extrema, you're looking for a place where the first derivative changes sign. And that's going to happen at critical points. It can't change sign anywhere other than a critical point, but we only have one critical point and it's not changing sign there. So there's no sign change, which means there's no maximum or minimum here. So there's the answer to part C. Y has no relative extrema because y prime never changes sign. A sign change in y prime is the thing that tells you when you have a maximum or a minimum. The next two questions are going to rely on the second derivative. So part D is asking us to find where is the function concave up or concave down. And we can see that in the second derivative sign chart. concave up on that left interval, concave down on the right interval. And then where does it change, or sorry, where is the inflection points for part E? That happens whenever the second derivative changes sign. And that does happen in the second derivative. The first derivative never changed sign, but the second derivative does. So we do have an inflection point. So we'll write those up next. So here are all my answers. Pause the video here if you need to have some time to look at this. And really what I want you to see is the big picture of 4 steps with the first derivative. Find the first derivative, critical points, sign chart, answer questions. And then those same 4 steps with the second derivative. The only difference is instead of answering questions about increasing, decreasing, maxes and mins, you're answering questions about concave up, concave down, inflection points.